ಓಕೆ, ವೆಲ್ಕಮ್ ಬ್ಯಾಕ್ ಟು ಮಾಹಿತಿ ದುನಿಯಾ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ ಮೈ ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್. ಈ ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ VTUs ಸಂಬಂಧಪಟ್ಟ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ಸ್ಗೆ ಸಂಬಂಧಪಟ್ಟ ಒಂದು ಡೆರಿವೇಷನ್ ಇರುತ್ತೆ. ಗಾಸ್ ಲಾ ಅಪ್ಲೈ ಟು ಡಿಫರೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಮ್ ಎಲಿಮೆಂಟ್. ಇದಕ್ಕೆ ನಾವು ಕಾರ್ಟೇಷಿಯನ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ನ ತೆಗೆದುಕೊಳ್ಬೇಕಾಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಡಿಫರೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಮ್ ಎಲಿಮೆಂಟ್. ಸೊ ವಿ ಹ್ಯಾವ್ ಕನ್ಸಿಡರ್ ಡಿಫರೆನ್ಷಿಯಲ್ ವ್ಯಾಲ್ಯೂಮ್ ಎಲಿಮೆಂಟ್ ಪಾಯಿಂಟ್ P XYZ ಇರುತ್ತೆ. ಕಾರ್ಟೇಷಿಯನ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮಲ್ಲಿ ನಿಮ್ಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ ಅದರ ಡಿಫರೆನ್ಷಿಯಲ್ ಎಲಿಮೆಂಟ್ DX DY DZ ಇರುತ್ತೆ. ಅದರ ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಎಕ್ಸ್ಗೆ AX, ವೈಗೆ AY, ಝಡ್ಗೆ AZ ಇರುತ್ತೆ. ಸೊ ಬೇಸಿಕಲಿ ಅದನ್ನು ಡಿಫರೆನ್ಷಿಯಲ್ ಎಲಿಮೆಂಟ್ ಆಗಿರೋದ್ರಿಂದ ಡೆಲ್ಟಾ ಇನ್ ಎಕ್ಸ್ ಡೈರೆಕ್ಷನ್ ವಿಲ್ ಟೇಕ್ ಡೆಲ್ಟಾ ಎಕ್ಸ್, ವೈ ಡೈರೆಕ್ಷನ್ ಡೆಲ್ಟಾ ವೈ, ಝೆಡ್ ಡೈರೆಕ್ಷನ್ ಡೆಲ್ಟಾ ಝೆಡ್. ಸೊ ಈ ಥರ ನಾವೊಂದು ಕ್ಯೂಬಿಕ್ ಸ್ಟ್ರಕ್ಚರನ್ನು ಬರ್ಕೋಬೇಕಾಗುತ್ತೆ. ಸೊ ಟೋಟಲಿ ಇದಕ್ಕೆ 6 ಫೇಸಸ್ ಇರುತ್ತೆ ನಮಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ: ಫ್ರಂಟ್, ಬ್ಯಾಕ್, ಸೈಡ್, ಲೆಫ್ಟ್, ರೈಟ್, ಟಾಪ್, ಬಾಟಮ್. ಓಕೆ, ಸೊ ಗಾಸ್ ಲಾ ನಮಗೆ ಗೊತ್ತಿದೆ, ವಿಚ್ ಇಸ್ ರಿಲೇಟೆಡ್ ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಡೆನ್ಸಿಟಿ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ at point P can be written as with respect to x, y, z like this. At origin we can write this x as x naught, y as y naught, and z as z naught. So later we can write by considering total 6 phases, since we can write the Gauss law like surface integral of closed surface integral of d dot ds. These surfaces are totally 6. So those 6 surfaces you can write multiplied by d dot ds. So now we will examine one by one. So first we will go for front and back, later we will see. So if you go for the front surface, so in this front surface I have taken, in the front surface, so it is, this side is y, so it is delta y, this side is z, it is delta z. So the unit vector which is perpendicular to this y and z is given as AX. So here now we want d and ds. So since it is a front surface, we can write it as d front. D front vector is equal to d front multiplied by AX. Why it is? So it is vector is equal to scalar multiplied by unit vector. Why you have considered x? Because it is a front surface, the perpendicular direction is x-axis. Y and z are okay, the other sides. Next, ds front vector is equals to, so differential surface vector which is perpendicular to AX is multiplied delta z, delta y, and AX. Okay, next, whatever this d front is there, that is front surface electric flux density, is varied in x direction and also with respect to the point, origin point x naught, as dx naught plus the rate of change of dx in x direction, how it is going to vary, multiplied by the distance of this surface from the point P. Suppose if I consider this is a surface, front surface, the point P is here, the total distance is delta x, but this is at the center point of this cube, hence it is delta x by 2 we should consider. So that is d front. Next, this d front substitute in this. So before that you can write front d dot ds is equal to d vector front and ds front. Since this is a differential element, the small surface, we can ignore the d as the constant and you can take without the integration. If it is a large area, consider the integration. If it is a very small area, remove that integration symbol. So we will write the Gauss law as by removing this, and front is added. So d vector front, take this and write here, ds front right here. So ax dot ax we know 1, so d front and this as it is. D front we know that we have written here, so right here. So it is a front surface we have written. Similarly, go for the back surface. So back surface I have considered, and in the back surface, very important observation is you can do here, back surface, this is the back surface. Okay, so with respect to this point P, the x direction is in the minus x direction, it is positive and it is negative. From this point to this surface, it is minus negative x direction. So that negative x direction can be written as minus ax vector. Okay, and the distance is again, it is delta x by 2. So from this point P to this is delta x by 2. So this back can be written as, again, the vector is equal to scalar multiplied by unit vector, but unit vector in negative direction. Similarly, ds back, differential surface back vector, can be written as delta y, delta z, and minus ax. So next, d back can be written as, at point origin dx naught, negative here because of minus delta x by 2. So the same thing here, it is positive, but here it is negative because of negative direction. Okay, so everything is same. Take the dot product ax dot ax1 and do the mathematical here, then you are going to get this. Okay, so you can compare this and this, so you are having this minus, and here the rest is same. So now once we get this, so we are going to take this addition of front d dot ds plus back d dot ds. So add these two. So if I add these two, so here this plus dx naught minus dx naught get cancels. This delta yz is there, so I will write delta y and delta z. But here we are having dou by dou x of dx, and here it is dou by dou x of dx. So 2 times you will get, here it is delta x by 2, 2 will get cancels. So you will end up with dou by dou x of dx. Okay, so you will get this. Now once you get this, so it is for which surface? It is for both front and back surface. Similarly, do it for top and bottom surface. So if I consider for top and bottom surface, so look at the RHS. So RHS delta y delta z. So here I am missed out delta x, because delta x by 2 it is delta x. So delta x will be there. Okay, so here what is going to happen with respect to this? Dou by dou z it becomes, and it is dz becomes, because top and bottom surface. Look at here, top surface and bottom surface. Suppose if I take the line like this, it is top and bottom, so it is along which axis? Z axis. So that is what you should consider this. Similarly, consider left and right. If you consider left and right, this becomes dou by dou y of dz, delta x delta y delta z. If I take this line, it is right and it is left. So what is this line? This line is corresponding to y. Okay, so like this, so you should consider. So now you got all faces. So here it is front, back, top, bottom, left, right. Add all faces. So you are going to get closed surface integral of d dot ds. So adding all these, so you are going to get delta x, delta y, delta z as common, and you are going to get with respect to x like this, with respect to y like this, with respect to z like this. Okay, so here this differential volume can be written as delta x, delta y, delta z. So here overall you can write surface integral of d dot ds, Gauss law, is equals to dou by dou x of this, dou y of dy, dou by dou z of dz multiplied by delta v. So this is total charge enclosed in the Cartesian coordination system for the differential volume element. Okay, so this is how we should solve the derivation part of Gauss law applied to differential volume element. Okay, so first go for the front and back. Okay, so once you write like front and back, then for top and bottom you just write similarly, and for left and right similarly. So this question can be asked for 8 marks. Okay, so Gauss law applied to differential volume element. Thank you. We'll see in the next video, the next update.